optical illusions. Motion after effect. Stare at the center of this moving image. When I tell you to look away, everything around you will appear to zoom and move, creating a kind of breathing effect. This happens because your eyes adapt to the movement, and when you look at something stationary, it takes a while for your eyes to readjust. Now, look around you. Do you see it? Ames room. Watch this person in an Ames room. When he moves to the left side, he appears small, but on the right side, he looks gigantic. Surprisingly, both sides of the room have the same height. The room's design makes the right side closer to the camera, making the person appear larger. Flashed face distortion effect. Stare at the center of this cross. The faces on the sides start to appear deformed and grotesque. This phenomenon was discovered by chance, and there isn't enough research yet to fully understand why it happens. Stepping feet illusion. These two buses seem to move step by step, but watch what happens when I remove the black and white stripes in the background. This effect is mainly caused by the contrast between the buses and the background. Silencing effect. If you look at the center of this image, you can see the small balls changing color. But when the balls start rotating, they seem to keep the same color, even though they are still changing. This occurs because it's harder to notice changes in moving objects. After image. Stare at this image. When I show you a white screen, you'll see a negative after image, which in this case will be cyan on magenta. This happens because the chemical activity in your retina continues even when the original stimulus is gone. Color dove illusion. Stare at the 4 dots in the center of this image. This illusion uses the same mechanism as the after image effect, but creates recognizable shapes like faces. You should be seeing a picture of Jesus right now. Impossible object. An impossible object is a 2-dimensional figure that is perceived as a projection of a 3-dimensional object that cannot exist. The animation you're seeing is called the Penrose stairs. Other variations include the Penrose triangle and the impossible cube. Hybrid image. In this image, you'll see Albert Einstein from a short distance and Marilyn Monroe from afar. This happens because the image combines the low spatial frequencies of one picture with the high spatial frequencies of another. Ponzo illusion. The upper line looks longer because we interpret the upper part as receding into the distance. This is caused by the same mechanism that makes us perceive 2D images as 3D ones. Poggendorf illusion. It seems as if the blue line is the continuation of the black one, while it is actually the red one. This is caused by the properties of the obscuring pattern and the nature of its borders. Forced perspective. This technique makes an object appear farther away, closer, larger, or smaller than it really is. Tourists taking a photo of the Leaning Tower of Pisa in the famous pose are actually using this technique. Barber pole illusion. Did you know that the diagonal lines in a barber pole actually rotate horizontally and don't move up or down? The vertical movement is just an optical illusion. Zöllner. Illusion. These lines are not perfectly parallel, right? Look at what happens when I remove the shorter lines. The angle of the shorter lines creates the impression that one end of the longer lines is nearer to the viewer than the other end. Café wall illusion. These lines are actually parallel and straight, but they appear sloped because white areas seem larger than black ones. This effect disappears when the colors are changed. Wundt illusion. Are the 2 red lines straight or bowed inwards? They are actually straight but appear distorted because of the lines in the background. Fraser spiral. This is also known as a false spiral, as the overlapping black arcs are actually just a series of concentric circles, not a spiral. Vertical horizontal illusion. Which of these 2 lines is the longest? Neither. They're both the same length. If you guessed the vertical one was longer, you've been tricked. Crater illusion. This illusion causes craters or other holes to appear as mountains or domes. One of the most accepted theories is that it's caused by our being accustomed to seeing light from overhead. Kanizsa triangle. This image gives the impression of a bright white triangle, despite the absence of lines or color change across the edge. Some people perceive the illusory triangle as brighter than the background and closer to the viewer. Kinetic depth effect. This spinning dancer can be seen to be spinning in both directions because there's a lack of visual cues for depth. For example, the dancer's arms can be perceived to be moving in the foreground between her and you, or in the background behind the dancer's body. Rotating snakes. These circles are stationary but appear to be moving. Contrast and small involuntary eye movements seem to play a huge role in this illusion. Turnus illusion. In this GIF, it seems like only one circle is moving. If we add a small blank frame, it seems like they are both moving. This is closely linked to Gestalt psychology and is a type of apparent group motion. Beta movement. Here's another example of apparent motion, which was used in the famous snake game. This makes you perceive movement instead of some random circles appearing and disappearing, which is what is actually happening. Phi phenomenon. In contrast to the beta movement, this one does not include any movement of the circle, just the disappearing of them, but it still creates a movement perception. Lilac chaser. This illusion has 3 steps. First, you see a gap running around the circle, then a green disc running around the circle of lilac discs in place of the gap, and finally, you stop seeing the lilac discs and just see a green disc running around on the gray background. Gravity Hill. It's a place where the layout of the surrounding land makes a slight downhill slope seem like an uphill slope, like in this image where the water seems to run uphill. Ebbinghaus illusion. The 2 orange circles are exactly the same size, but the difference in surrounding circles makes it seem like the right one is larger. Stroboscopic effect. If I show you this GIF, you perceive the clock hand as moving from right to left. But look at what happens if I start to cover it for small periods of time. This effect is closely linked to the wagon wheel effect, which makes you see propellers of helicopters or airplanes as stationary, moving slowly or moving backwards. Basold effect. In this image, the red lines on the white background are lighter, and the ones on the black background are darker, or so it seems. Horizontal red lines have the exact same color, but the backgrounds create this illusion. Ehrenstein illusion. The sides of a square placed inside concentric shapes take on a falsely curved shape. Sander illusion. The diagonal line in the left parallelogram seems longer than the one in the smaller right parallelogram, but they are the same length. This might happen because the diagonal lines around the blue ones give an illusion of depth. Miller-Lyer effect. The 2 lines are actually the same length, despite their arrow-like ends making them seem different. Hermann grid illusion. Ghost-like gray blobs seem to appear in the white intersections of a black grid, but only if you don't look directly at them. Rubens' vase. Is this a vase, or are they 2 faces looking at each other? This is an example of ambiguous 2-dimensional forms and a perfect demonstration of the figure-ground distinction the brain makes. Contrast illusion. The contrast illusion happens when there's a distortion in perception of a stimulus when that stimulus is presented after or simultaneously with another one of lesser or greater value. For example, the red dots on the right side appear darker than those on the left side, but they both have the same color. Mach bands. Your eyes exaggerate the contrast between edges of slightly different shades of gray when they touch each other, because it triggers the edge detection system. Leaning tower illusion. Can you believe that the tower in the right photo does not lean more to the right? It's an exact duplicate of the photo on the left. Hollow face illusion. The perception of a concave mask of a face appears as a normal convex face. This could be a demonstration of the power of top-down knowledge for vision. Color constancy. How can you still know what colors things are in this photo while it is composed of only light and dark shades of red and white? It's thanks to color constancy, a feature of the human color perception system. Thanks for watching my videos. Don't forget to subscribe and like for more content like this. See you next time.